Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn about the relationship between two categorical variables. All right, so first we have some vocabulary. The response variable measures an outcome of a study. The explanatory variable may help predict or explain changes in a response variable. The segmented bar graph or bar chart displays the possible values of a categorical variable as segments of a rectangle, with the area of each segment proportional to the percent of the individuals in the corresponding category. A two-way table is a table of frequencies or relative frequencies. So remember, frequencies are counts, relative frequencies are percentages, that summarize the relationship between two categorical variables for some group of individuals. All right, let's do our first example. Identifying explanatory variables. Identify the explanatory variable for the following relationship. Explain your reasoning. So, age of students and whether they are allowed to stay up past 11 p.m. on school nights. All right, I would say that the explanatory variable is age because knowing a student's age will help predict whether a student is allowed to stay up past 11 p.m. Okay, typically as students get older, their bedtimes get later. Part B, the average hours of study time per week and the average hours of extracurricular activities per week for a sample of students. I'm going to say that the explanatory variable could be either. Either variable could predict the other. So if you have if you're spending a lot of time studying, that may mean you have less time for extracurriculars. Or if you're spending a lot of time doing extracurriculars, you may have less time studying. So either one could be the explanatory variable. All right, making a segmented bar chart. Data on sex and whether a person had allergies were obtained from a random sample of 227 students who responded to a survey on the Census at Schools website. So we have males, females, and whether or not they have allergies. All right, so we have their total, so the total number of females, total number of males, total number of people with allergies, without allergies. Make a segmented bar chart to display the relationship between allergy status and sex for the students in this sample. So I need to find these conditional probabilities. So for females, I had 50 females that said yes out of a total of 130 females. So 39% of females have allergies, and 80 out of the 130 females do not have allergies, so 62% do not have allergies. I'm going to do the same for the males. 34 out of the total for males is 97. 63 out of the total for males gives me 65% and 35%. So now I'm going to make my segmented bar chart. I am going to have percent or relative frequency along the y-axis, and it's always going to go up to 100%. Every time you make a segmented bar chart, it's always out of 100%. I'm going to have my two categorical variable or my categories, male and female, on the x-axis. Whether or not they have allergies, I'm going to make a little key. If you don't have colors, you can just shade one in and then not shade the other, or put dots or stripes or something. All right, so females, we're going to 62% that do not have allergies, and 39% do. So together we stack those so that it makes 100%. All right, and then males, we have 65% that have no allergies and 35% that do have allergies. Okay, and that is a segmented bar chart. All right, association. There is an association between two variables if knowing the value of one variable helps us to predict the value of the other. If knowing the value of one variable does not help us to predict the value of the other, then there is no association between the variables. All right, so we're going to check for an association. Use the graph to determine if there is an association between survival status and class of travel for passengers on the Titanic. Explain your reasoning. If there is an association, briefly describe it. Okay, so we have first class, second class, and third class, and then whether they survived or died. All right, and so I can see that the bars are not even, right? So like if everything for survived was all about the same height, then we would say that there is no association. But because they're different heights, That means if I know that they were first class, I know that they had a higher percentage of surviving versus if they were third class, they had a higher percentage of dying. All right, so we're going to say there is an association between survival status and class of travel because the survival rates were not the same for different classes. Passengers in first class were most likely to survive, and passengers in third class were least likely to survive. All right, go Seahawks.